So we've used our trig functions to evaluate the trig functions of some acute angles of a right triangle. But the other major thing that we can really do with these trig functions is what's known as solving right triangles. Alright? And all that really means is we can figure out what all the angles and what all the sides are in a right triangle as long as we're given one angle and one side. Okay? So, first example here is they tell you suppose leg A, right, is 9 inches and angle B is pi over 5 radians. So the first thing we have to do really is set up our picture accurately. So what we would do is we would draw a right triangle. Alright, there's our right angle. So that right angle there has got to be C. And then really it doesn't matter which angle I call A or B. So let's just say I call this A and this B. Right? It didn't matter which one I called angle A, which one I called angle B, but now that I've chosen the angles, side A has to go opposite angle A and side B has to go opposite angle B, right? Because that was the setup for the right triangle, and of course the hypotenuse is C, which is opposite the right angle. So the things that are known here is that A, right, little side A, leg A is going to be 9 inches and angle B is going to be pi over 5 radians. Alright, now the first thing always to do in these is just get the other angle, because the other angle is the easiest thing to find. So if I know one angle is pi over 5, I know those two angles, A and B, are complementary, so they add up to, in radians, pi over 2. So I know angle A is just going to be pi over 2 minus the other angle, which is pi over 5. And what you're doing here really is you're getting a common denominator of 10. So this is really 5 pi over 10 minus 2 pi over 10. So the other angle, which is angle A in this case, is 3 pi over 10. So that's the easy thing. The easy thing is just getting the other angle, because there was no trig involved there. It was just knowing that they're complementary. So they add up to pi over 2 radians, or 90 degrees if it's in degrees. Alright, so now let's say we want to find leg B. So if we want to find leg B, what we got to realize first is what we're given. We were given this angle here, pi over 5, and this leg here, which is 9. So with respect to this angle, pi over 5, leg B is opposite and leg A is adjacent. So which one of our trig functions, right, sine, cosine, tangent, dealt with the opposite and the adjacent? Well, that was tangent, right? So tangent is what we're going to use here to find side B, because we're dealing with the opposite and the adjacent. So what was the definition of the tangent of an angle? The tangent of the angle, which in this case the angle is pi over 5, was always equal to, right, the opposite, right, because this was SOHCAHTOA, so we're at the TOA part. So the tangent of pi over 5 was equal to the opposite, right, which is the thing we're trying to find, which is B, over the adjacent, which is 9. So that's my equation to solve. The tangent of pi over 5 equals B over 9. And you look at this and you might be a little confused thinking, how can I solve this? Well, it's really just an equation that has one unknown, right? The tangent of pi over 5 is just a number that we can get on our calculator, which we will do now. Alright, so when we do this, the first thing we have to do is remember that we're in radians here, so we have to go to mode, right? Hit the mode button and make sure that we are in radian mode, and we are, so we're okay. So we have the tangent of pi over 5. We can figure out what that is just by entering it in the calculator here. So there's the tangent of pi over 5. What is it? It's that decimal there. Alright? But before I even enter that decimal, what I'll probably do is get this solution in exact form. So what would I do here? I could basically multiply both sides by 9. So then that would get rid of the denominator of 9, and I'd end up with b equals 9 tangent of pi over 5. And that's your exact answer there, right? That's the exact length of the leg, 9 times the tangent of pi over 5. But if I want to get the approximation, I would just put the tangent of pi over 5 in there and then multiply by 9. So I get 6.54, let's say. So the other leg in this case would be 6.54, and this is measured in inches. So there's my one length. And now let's say I want to find the hypotenuse, right? Again, what I'm going to do is I'm going to go back to my given info. My given info was the 9 inches for this leg and the pi over 5 radians for this angle. So in relation to pi over 5, right, C, of course, is the hypotenuse, and again, the 9 was the adjacent. So I'm dealing with the adjacent and the hypotenuse. So which trig function dealt with the adjacent and the hypotenuse? Well, that was the c part, which was cosine, right? So in this case, the definition would be the cosine of the angle, which is pi over 5, is going to be equal to the adjacent, right, the leg adjacent, which is 9, over the hypotenuse, which is c, which is what I'm trying to find. Okay, now this one is slightly different than the first one, because in this one, if I cross multiply, the 9 is just multiplied by 1, so 9 times 1 is 9, and then I have c times the cosine of pi over 5. But again, realize that the cosine of pi over 5 is just a number, right? It's just a value that I can divide by. So I end up with 9 divided by the cosine of pi over 5. And again, that's your exact answer. If you want an exact answer, it's the fact that c equals 9 divided by the cosine of pi over 5. But generally, you want to approximate these things. So I want to do 9 divided by the cosine of pi over 5 on the calculator, and it'll give me 11.12 inches. Alright, so there's my other side, right? My hypotenuse is 11.12 inches. See, and the nice thing about doing it this way is now I can actually do kind of like a check on the calculator. I can do a check using the Pythagorean theorem, right? I can kind of make sure that if I do a squared plus b squared, which is 9 squared plus 6.54 squared, that's 123.7716, I get the same thing as when I square c, right? A squared plus b squared equals c squared. So this should be equal to that. And you might look at that and say, ooh, it's not equal. Well, it's not exactly the same because of the fact that I rounded. But it's close enough to kind of tell me that, yes, it works, right? So this is a valid. The other leg, which was 6.54 inches, and the hypotenuse, which was 11.12 inches. So I solved that right triangle, given one angle and one side in the right triangle.